Hi, this is Lauren from Governor State University's STEAM Camp. Today I'll be showing you how to make an origami butterfly. This is pretty fun. They come out really cute at the end. This design is created by Kawasaki, and we'll be using Kawasaki's theorem to figure out whether this is flat foldable, as well as Maekawa's theorem, which is the flat foldability theorems. They both figure out whether a design is flat foldable, but Kawasaki's theorem deals with angles, whereas Maekawa's deals with number of folds. So to begin, I have my paper out in front of me that it's the folding diagram. So the red represents mountain folds and the blue represent valley folds. Now looking at this, you probably have an idea whether or not this is whether or not it's flat foldable, but the results might surprise you at the end. I will show you Maekawa's theorem and how it relates to this. Here's the flat foldability, here's the diagram a little bit closer. As I stated before, the red equals mountain folds and the blue equals valley folds. So looking at this, I've zoomed in to a picture right here, and it looks at the angles at the lower left side. So angle 1 is approximately 45 degrees, angle 2 is approximately 45 degrees as well, angle 3 is approximately 135 degrees, and angle 4 is approximately 135 degrees. Now looking at Kawasaki's theorem, their theorem states that a crease pattern is only flat foldable if the alternating sum of incident angles at any given vertex is always a 0. And the equation for this is as follows. It's a1 minus a2 plus a3 and so on equals 0. So looking at this, you can see how, because the number of degrees is the same and they cancel out, this part of the thing is flat foldable. But if we look more towards the center of the diagram, you'll see that it is not exactly flat foldable. I don't sort of feel like looking at all of these angles because that requires a lot of thought, and I don't quite have the wherewithal for that. But looking at the lower left side of this as well, you can see that the angles definitely do not match up all the way. There are some that are much larger and some that are much smaller than the other ones. There's some lines that don't even connect to one given vertex, so you can see that the butterfly is in fact not flat foldable. And then if we were to look at Maekawa's theorem in regards to this, there are 84 mountain folds and 62 valley folds, meaning that there are 22 more mountain folds than valley folds. So even with Maekawa's theorem, this is not flat foldable. So I am bringing out my paper in front of me. Mine, of course, is single-sided, so one side is white, one side is orange. I am folding my square piece of paper in half, making a nice straight edge there, creasing it firmly. Then I'm opening that back up and bringing the top half of my paper to meet the middle line that we just made, and creasing that. These are all, of course, valley folds. Or mountain folds, depending on which side of the paper you're looking at. And then that bottom piece of paper is going up to meet the top half of the paper that you just folded, sort of like you would fold a letter that's going into an envelope. And I'm creasing that nice and good. I'm folding that piece of paper in half. Creasing it. And the top half of the paper, there's a line that you'll see. You want that to be towards the center. You're folding the pieces of paper towards the center of your paper, of the crease you just made, and you want where that crease is to be towards the center of the paper. It looks almost like a tent or a house or something. And I'm opening that back up. And you will have to recrease all of your paper, so you're making those valley folds into mountain folds, which that'll help with a balloon base, which we've done that before. This is sort of different from that because there is one straighter side. Creasing my folds again, and I'm bringing those in to meet the center, and folding the top part down into a squash fold, and that's a balloon base but with a longer end. And I'm smoothing everything out. There you go. There's one side that has some orange on the bottom, and there's one side that doesn't. I'm taking the side that doesn't have the orange at the bottom, not the side that does have the orange on the bottom, and I'm bringing the edges in to meet the center. So the white part of the paper is going in to meet the center, folding that in half, doing the same with the other side. Alright, that's one part of the paper. The butterfly is close to done, whether you believe it or not, and I'm flipping it over to where the bottom has the orange sides. I'm folding those orange sides down. There's about, I would say, a centimeter of space there. It'd probably be less because you have smaller paper than me. Creating triangles there, almost like you would dog-ear a page. And I'm bringing the corners on the inside of the paper and folding them down on top of the folds you just made of like the dog-ear folds. Your paper will sort of look like a heart now. And I'm bringing the bottom half of the paper where it's like a triangle, bringing that up, creasing that, flipping it over, pulling that top of the triangle down. There's the head of the butterfly. It's almost done. Creasing that. Look at you. Okay. And I'm bringing the top half, I'm creating an accordion fold there. I don't know if you can see. It helps form the face of the butterfly a little bit better. And I'm just creasing the inside of the butterfly to create the body. There you go. You can sort of see how I did that. I just took the center. Oh, look, it's flying away. Yeah, so that's how you complete a butterfly. There are more instructions on the PowerPoint if you want. I've also included a link in the description. So, let me know what you think. I hope you had fun with this one.